Welcome to the video. Here is the most expensive mistake in AI engineering right now. We build the thing first and only afterwards try to work out whether it is any good. Let's do it the other way around. Decide what good means, then build toward it. You have seen this moment. The demo works, the room nods, somebody says, let's ship it. What that is built on is 5 examples and a feeling. Case 6 onwards, nobody checked. So how do you know it is good? Not for the 5 you tried, for the thousands you have not. In normal software, it is requirements, code, test, ship. Nobody argues about the test step. Here is what a lot of teams do with a language model: prompt, agent, demo, ship. The test step did not get harder, it got skipped. And that is the whole problem in one picture. So here is the shift. Instead of building and then hoping the tests agree with you, you define quality first, build toward it, measure, improve. And I want to push that further. The measurement should not just grade the design you picked, it should choose it. You might be thinking this is just test-driven development. It is not, and here is why. A unit test is a single point. 5 plus 5 is 10 on every machine every time. Ask a model the same question 10 times and you get a spread. Excellent, mostly right, correct but useless, a confident hallucination. You are not testing a value, you are testing a distribution. So the first real engineering act is turning a wish into a spec. Build a customer support agent is not something you can build against. This is task completion above 90%, answers grounded in our own documentation 95% of the time, tool calls correct 90%, 0 critical safety violations, and a P95 latency under 3 seconds. That is a definition of done that you can hold a system to. But who does the grading? There are only 3 answers, and you will use all 3. Code: exact match, a regular expression, a unit test, a check that the database row actually changed. Fast, cheap, reproducible. It breaks the moment a valid answer is worded differently. A model: you write a rubric, another model applies it. That handles open-ended work code cannot touch, but it is non-deterministic and costs money every run. And humans: the gold standard and what you use to calibrate the other two, also slow, expensive, and it does not scale. Whatever framework you pick will hand you a long list of metrics. Do not turn on all 50. Pick 2 or 3 general ones and 1 or 2 specific to what you are building. 5 is plenty. Measure everything and you have prioritized nothing. And if you are building agents, this all gets harder because you are no longer scoring one output. You are scoring a trajectory. It plans, it calls a tool, it looks at what came back, it calls another one, and eventually it answers. The instinct is to check it followed your exact steps. Resist that. Good agents keep finding valid routes you never thought of. Grade what it produced, then track what the path cost you. And there is one number here most teams never look at. Pass at K asks, did it succeed at least once? Pass to the K asks, did it succeed every time? At 75% per run, 3 runs all passing is only 42%. If a customer touches it, ship against the second one. Here is where measurement stops being a report card and starts being design. Say you have a simple setup. A question comes in, you retrieve documents, the model answers. Faithfulness comes back at 91, against a bar of 95. On its own, that number tells you nothing. Paired with the others, it does. Faithfulness low, while retrieval is healthy, means the model is drifting from its sources. Recall low means retrieval never found the answer. Same symptom, different fix. Here it was the first. Add a re-ranking step and it clears the bar at 97. That is an architecture change chosen by a number, not by an argument in a meeting. That only works if you score every hop, not just the ending. A wrong answer at the end has 4 suspects behind it. Extraction scored low. Routing was fine. The tool call was fine. The decision looked reasonable. The answer was still wrong. This is the pattern I see most often. The last step gets blamed, but its reasoning was sound. It was working from data that lost something 3 stages earlier. Without a score on every hop, you spend a week tuning the wrong prompt. So which 5 do you actually pick? It depends where in the system you are measuring. At retrieval, 3. Recall, did we fetch everything the answer needed? Precision, is the useful material ranked above the noise? Relevancy, how much of what we fetched was junk? At the output, faithfulness, is every claim traceable to the context? Answer relevancy, does it answer the question actually asked? And the deterministic ones, is the format valid and is anything leaking? For the agent, did the end state actually change? Was the right tool called with the right arguments? And what did the trajectory cost you in turns, tokens, and time? And notice the pattern. Retrieval and wording need a model to judge them. Agent success is mostly countable in code. Whichever column goes red tells you what to change. Now here's the idea that turns this from a testing habit into engineering. Imagine a system reading receipts, 3 failure modes measured. The merchant name is wrong 85% of the time. Sounds terrible. It changes no decision, so it costs nothing. A missed handwritten mark is rarer and worth 75,000 a year. Arithmetic errors up to 400,000. The worst scoring metric was the one worth ignoring. Put a currency value on each failure and your scoreboard becomes a budget. That is what tells you where the next 2 weeks go. So, how much test data do you need before any of this works? Less than you think. 1,000 generated cases tell you the same thing 1,000 times. 20 to 50 drawn from real failures teach you more because they actually happened. Take them from your bug tracker and support queue and test both directions, where the behavior should fire and where it must not. Now, the part nobody puts on a slide. Most of these scores are produced by another model. So, it is worth knowing how judges behave. Show one the same 2 answers twice, swapping the order, and it can pick a different winner. There is a large study on exactly this. 21 judge models, over 500,000 judgments. Consistency above 0.95, so they are extremely stable. But flip the order and rankings moved by up to 14 places. Consistent is not the same as correct. A judge can be perfectly reliable and reliably wrong. So evaluate the evaluator. 4 habits. Be explicit with a rubric per dimension and a way to answer unknown. Go deterministic wherever you can. Swap the order to cancel bias and never let a model grade itself. And read the transcripts. That is the only way to know a grader works. So your score comes back low. What do you actually change? Work down this list. Never up it. A better model or more reasoning budget. Then the prompt. Then examples and context. Then tools, so it can look things up instead of guessing. Then helper models. And only then, fine-tuning. Fine-tuning is last for a reason. Fine-tune on a weak prompt and you bake that weakness into the weights. The score is what tells you which rung you are standing on. Let's put the whole thing together. A request comes in, passes an input guardrail, reaches the agent loop, which reaches for retrieval, tools, and memory, then back out through an output guardrail. Anything high stakes goes to a human. And these are the 6 places you can tap it. The input, for scope and safety. Retrieval, did we fetch the right context? Tools, was the right one called correctly? The loop itself, the outcome plus what it cost, the output. And production, where the traffic is real. And this arrow is the one that matters most. Every failure you see in production becomes a test case at the front of the pipeline. That is the loop that compounds. One last thing, because none of those layers catches everything. Automated tests run on every change, but only know what you thought to write down. Monitoring sees what users really send. A/B tests say whether a change helped. Feedback is sparse, skewed, and completely real. Human review calibrates all of it. Every one of those layers has holes in it. Safety engineering has a name for this. You stack the layers so the holes do not line up, which leaves you living inside one loop. Define success, build, measure, diagnose which component, then change the system, not just the prompt. And one warning about that loop. When everything goes green, that is not victory. It means your tests have stopped telling you anything and it is their turn to get harder. So, the old question was, does my AI work? The new one is, can I prove it? Your AI application is probabilistic. Your engineering process does not have to be. Decide what good means before you build. Put a value on each failure, grade the outcome, and track what the path cost. And then evaluate the judge too. Thanks for watching.